factoring review. So the first step is to check for a GCF. I see that both of these factors have x in common. So when I factor out an x, I have an x left over. And when I factor out an x from negative 4x, I have negative 4 left over. This means I have two factors multiplied by each other and they make 0. So I'm going to solve for both of them. I have x equals 0 and I have x minus 4 equals 0. I already know that x equals 0, so if I add 4 to both sides, I get x equals 4. So similar to our absolute value graphing, if I have x minus 4, it's the difference between x and 4 on a number line, right? This has the same type of behavior. So my zeros would be 0 and positive 4, even though it's 0 and negative 4. You see how it takes the same type of behavior that we've been talking about? Step equations, step functions, absolute value functions, linear equations, right? All of that, they have the same type of behavior. So this would be a graph somewhat like this. Questions? Yes?
How do you know where, like, we're going to catch the curve?
Yeah. We haven't gotten there yet. We're not concerned with that yet. Okay? Good question, but we're just not there yet. Right now, we're just trying to get the behavior of it. All right, let's look at this one. I don't want to know when it solves for negative 36. I want to know when it solves for 0. So I would move this over. So I have x squared plus 12x plus 36 equals 0. Actually, you know what I want you guys to do? I want you to go back and copy this one down into your notes. Okay, so for most of you, you should already see that this is a perfect square trinomial. Okay? You've got a square here and a square here. Adding them together and squaring them. Actually, let me write it like this. And I'll show you my whole rainbows and checks. X times x is x squared, right? And 6 times 6 is 36. See how I got that? Let's check it. 6x and 6x makes 12x. And that's what I have right there. So that's how I checked it. But if you don't know how to do that, we're going to do it a different way. So finally, let's see. Let's do it the other way and then let's solve for it. So draw my X box. I always do the box first because oftentimes the most common error is this. I'll show you right now. Okay, so this is A. Go back up here. This is C. Let me rewrite that. Let's do it right here. This is A, this is C, and this is B. A goes here, C goes here, and you're going to get two values for B right here. Okay? This is an array. You use them all the time. Most simplistically, you started using them back in elementary school when you used it for a multiplication chart. You never used this? No? Really? You've never used a multiplication chart? 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, right? Same concept. Same exact concept. And you know what? It's really, what I like about this is that you're going to have to use these later on anyway, in harder math. So we might as well get used to using them right now. But you don't have to do it this way. Okay, Jesus, and I'll show you exactly what I mean. Right? But I do want you to get comfortable with it because I'm going to be using it. but not all the time, because there's sometimes when this method works well, and there's sometimes when other methods work better. Okay? That's why I said I want you to be able to do multiple methods and really understand all of it. Okay? So, A is x squared, that goes here, and C is 36, which makes sense because if I was to fill this out, I'm kind of going in a diagonal fashion here. So I've got x squared plus two things that when you add them together make up 12x plus 36. See how that looks? We're kind of filling things out just like that. Now in order to find out what these two values are, these two b values are, I can use this funky x thing. If I multiply a times c, I get 36x squared. B goes in the basement. We call this the attic. A and C, the attic. B goes in the basement, which is 12x. What two values? When I multiply, I get 36, but when I add, I get 12. 6x and 6x. There are my mystery B values, right there. So, in order to factor this, I need to find the common factors. X times x is x squared. X times 6 is 6x. What do these two have in common? A 6. 6 times x is 6x. 6 times 6 is 36. There it is factored. X plus 6 times x plus 6 equals 0. Do I really need to evaluate both of those? They're exactly the same, right? So I really only need to solve for one of them. X equals negative 6. If there's only one solution on a graph, that means that it must only touch one. It just scrapes right next to it. Okay, Evan, question.
Can you do you know where we have the A and X plus 6?
Uh-huh.
Can you do that before you find the 6 X?
Yes. But here's what happens. For students that do the x first and do 36x squared, then they go over here and they put 36x squared in this box right here. That is a very, very common error. So that's why I set up my box first, and then go over here and do the x and find the two values that go in this box. Yes, ma'am? They're both connected. This is one way to do it if you didn't see that there was a pattern here. Okay? So I was doing it both ways. Yeah. Yes. But this is what you have to show me, rainbows and checks. And I'm going to show you that in just 1 second as well. Yes? Using the quadratic formula? Why would you want to? This is easier than using the quadratic formula. Okay? That's why we got to practice it. The only reason to use the quadratic formula, right, is what? If you can't factor it. First, try and factor. Actually, first you try and use a GCF, then you try and factor. If you can't do either of those, you can try and complete the square. If you can't, because that one's even easier. If you can't complete the square, quadratic formula, in that order. Okay. Let's factor this one. I don't see a GCF. I don't see any square roots. So this is not a perfect square trinomial. We just have to factor this. I'm going to do it side by side. One of them is the guess and check method. The other one is the X box method. So I'm going to draw my box and my X, and I'm going to label, this is my A, 2x squared. This is my C, negative 3. I want to find B. So in order to find B, I'm going to go back over here. This B is negative x. My attic is 2x squared times negative 3 is negative 6x squared. What two numbers, when I multiply, I get negative 6, but when I add, I get negative x? Good job. Negative 3x and 2x. There's my values right there. When I factor this, These two have 2x in common. 2x times x is x2x squared. 2x times 1 is 2x. Negative 3 times x is negative 3x. And negative 3 times 1 is negative 3. You always kind of want to check, because when you start getting negatives in there, sometimes things can get a little bit funky. So when I factor this out, I get 2x minus 3 times x plus 1 equals 0. 2x minus 3 equals 0. X plus 1 equals 0. To solve this, this is a two-step equation. If you need help solving two-step equations, come by after school. Most of you should be able to do that in your head. Okay, let's look at the other way. This is the old school method. It's what I had to do when I was your age. Want to see how fun it is? All right, so I'm going to try and factor this by the guess and check method. I've got a 2x squared. That's not too hard. It's got to be 2x times x, right? Negative 3. I can see it over here, but let's pretend we can't see it. Okay? So let's just say I think the 1 goes here and the 3 goes here. I know one of them's got to be negative, right? Because if I make this 1 times 1, that's going to be positive 3. That's not a positive 3. If I make them both negative, negative 1 times negative 3 is positive 3. Can't be that either. So one of them's got to be positive. If I do that rainbow method, that rainbow check, guess and check, that's x, that's negative 6x. Does that work? No. Let's try something different. Let's try 3 and 1. Which one do you want to make negative? Really? This is a negative x. Negative 3x, positive 2x equals negative x. See how I'm checking it to make sure it matches? That is the second method. That's probably the one you're used to, right? No? Good. Does it work? Good. Okay, it works for you. So it's a different type of, how would you call it? If you're used to doing something already, go with it. But you need to be able to understand what I'm doing here when I'm doing it. Yes?
Well, the way I do it, I don't use the X and I start the box down.
Then don't. I've told you guys, right? This is the way I'm going to be doing it. Good. Do that. This is the way I'm going to be doing it. I don't think you guys are quite understanding me. You can do it your way, but if you get lost and I'm sitting up here, I can't do it 5 different ways. Right? This is the way I'm going to be doing it. Now on the next one I'm going to show you, I'm going to go back to the guess and check because it's really easy. But when I can't figure it out real quickly, I go to this method right here. Yes? Question? Can't you get the... Uh-huh. I don't know exactly what you're talking about. You have to show me. You do it and show me, did you get the same thing? Okay. All right, so I want you to be able to, I don't think we wrote the last one down, correct? So go ahead and write this one down, and then I'll let you write the other one down. And you can write down either way or your own way, but it's got to match the same answer, correct? Not. Also, we never completely solved this one. So now that we have our 2 factors equal to 0, change my color here. I still need to solve for this. So I have 2x minus 3 equals 0, and x plus 1 equals 0. Yes? Oh, thank you. That's right. I already did it. Thank you. That's what happens when you do this 3 times in a row, right? You kind of forget what you've already done. Question, yes? These right here? Okay, I'm factoring. So, what 2 numbers when I multiply, just like if you have a 6, what 2 numbers when you multiply do you get 6? 2 times 3. Right? It's the same thing as a multiplication chart. So what 2 numbers, and you can also look at it as what's the greatest common factor of negative 3x and negative 3? Negative 3, and it works out perfect. Negative 3 times x is negative 3x. Negative 3 times 1 is negative 3. And it will always work that way. Good question. How many of you have never been exposed to this method over here? Yikes. Okay. Yes. Good. So whatever method you're using is working for you. Good. Yes.
Can you just put that on the graph?
I'm not requiring you to graph these, but this would be at -1, and 3/2 is 1.5. Good question. No. This is just the zeros, which is the intersection on the x-axis. Yes. So no, I'm multiplying. I'm saying negative 3 times x is negative 3x, and 2x times 1 is 2x. Then I find the total together is negative x, and it's got to match the middle right there. Multiply and then combine. Yes. All right, let's keep going. All right, so for instance, this one. Go ahead and try this one on your own. Okay, so I'm going to start off with doing the guess and check method because this, to me, looks very easy to factor. I can see it. I don't have a leading coefficient here other than 1, right? So I know right from the beginning that x times x is x squared. That's a no-brainer. That has to be that, right? Now, what 2 numbers, when I add them, am I going to get 14, but when I multiply, I get 33? 11 and 3. So see how it benefits you to be able to go from one method to another method? That's easy now. X equals -11 and x equals -3. Right? See that? Okay, we got to do our rainbows and checks. Because if you're going to use this method, you got to show me rainbows and checks. So I've got 11x and I've got 3x, which makes 14x. Check. Do you see that, Nicole, how I did that? You still don't?
I still don't understand how you make the problem like x plus or not still
I said what 2 numbers when I multiply I get 33. 11 times 3 is 33. Right?
Yeah.
But when I add 11 and 3 I get 14.
Okay.
See that?
So you just forget the x next to the 14?
Yep.
Okay.
Okay, so, but if you didn't see it that way, Ryan, you would just organize it in this nice little box here. I've got x squared goes here, 33 goes here, and I'm going to use this guy over here to figure out how I'm going to break up that 14. Hold on, guys, you're not listening when you have hands up. I'll ask for questions in a second. So this is what's important to me. You've got to be able to see that A goes here, C goes here. I've got to split up B. So the way I'm going to split up B is I'm going to use this. 33x squared. The B I already have is 14x. So 11x and 3x make 14x. And when I multiply them, I get 33x. You see that, Ryan?
Yeah.
So now I know that 11x and 3x must be what I need to put here. It doesn't matter which order you put them in. Multiplication is commutative. It's still going to come out the same. So when I factor or plot the greatest common factor, they both have an x. X times what makes x squared? X. X times what makes 3x? 3. 11x and 33 both have an 11. 11 times x is 11x. 11 times 3 is 33. There's my two binomials right there.
Okay, that's better. Thank you.
You're welcome. Okay, so when I solve this, I get x equals negative 11, x equals negative 3. You're right. The first one is a lot easier. So if you can see it, use it. If you can't see it, now you have another method you can use. And it sounds like some of you may have another method as well. There's all kinds of methods with all different types of teachers. I'm trying to use what's consistent in Upland Unified. I went to lots of math conferences. This is the way that we were taught. Okay, we called it Project Impact. It was a 3-year program that all of the teachers went through that were math teachers. I shouldn't say all. Many of the math teachers went through, all the way from elementary school through high school. So this is what I'm going to be using, because this, a couple years down the road, is what all of the kids in Upland Unified that went through Upland Unified have seen. Does that make sense? Up until a couple years ago, I had never seen this. I didn't like it at first. Now that I've used it a few times, I'm like, you know what, this is pretty user-friendly. It's set up just like a matrices. How many of you have seen matrices? Okay, so that's coming up. All right, let's look at this one. Try that one out. All right, so I'm going to go straight to using this method right here. So 6x squared, negative 4, negative 24x squared, negative 5x, negative 8x, and 3x. Those are my factors right there. My common factor for here would be 2x. Change my color here. 2x times 3x makes 6x squared. 2 times negative 4 makes negative 8x. The only thing they have in common is 1. 1 times 3x is 3x. 1 times negative 4 is negative 4. There's my factors. Oops. 3x minus 4 times 2x plus 1. Pretty quick, right? And there's really, other than this step right here, there's no guessing involved in this method. It just comes out that way, no matter what. All right, so I get 3x minus 4 equals 0. 2x plus 1 equals 0. So x equals 4/3, and x equals negative 1/2. All right, I got to show you one more thing. What? Because this is a graph. This isn't the answer. This is the answer. 1 1/3 and negative 1/2. That's what we're finding here, is the root. Yeah, we're solving for each one of these. That's what it means by factor and solve. The factoring isn't what we're doing. We're solving for the roots of the quadratic equation. That's what we're doing. I think that's the piece that Algebra 1 didn't bring home for everybody, was we're not just factoring, right? We're finding something every time we do it. We're finding where a quadratic formula or quadratic equation crosses over that x-axis. That's what we're looking for when we factor. We're not just doing x boxes. That would be silly just to do that all day. For what? Okay? All right, this is the last thing I need to show you.
That's funny.
Thank you. 36x squared. I need 0 because I'm solving for zeros, right? 36x squared minus 25. Please don't pack up. I'll just make you unpack. you should automatically be looking for squares. These are squares. Specifically, this is the difference of two squares. Don't make your life any harder. When you see squares, utilize them. The difference of two squares means you put a plus and a minus, and you put the squares in. What are the two squares in 36x squared? So 6x times 6x makes 36x squared, right? And doesn't 5 and 5 make 25? It's factored. Difference of two squares. If you were to put this in an X box, it's not very fun. 36 times 25 is negative 900x squared. 0x would be negative 30x and positive 30x. All right, have a great day, guys. Okay, so since we have negative 30 and positive 30x, those go in here. Let me change my color.
Thank you, homework.
Hold on, please. 30x, and I'm recording. Negative 30x. And in here, this is where that 36x squared goes. And this is where my negative 25 goes. So you see this, how these cancel out when I do that? So when I factor this out, 36x squared and 30x squared has a 6x. 6 times 6x is 6x squared. 6 times 5 is 30x. And this is a negative 5 over here, makes negative 30x and negative 25. So it still works, what we got. But the shortcut is, if you see squares, the reason we call this the difference is because there's subtraction. The difference of two squares is because you can break it up because that middle term cancels out. So for instance, let's look at another one. What would x squared minus 4 be? X minus 2, x plus 2. See how negative 2x and positive 2x cancel each other out to have nothing in the middle? And 4x squared minus 9.
Yeah.
2x minus 3, 2x plus 3. Got it?
Yeah.
Easier?
Yeah.
Good. Good.
And so that's pretty much all we need to know for the homework tonight.
That's all you need to know for homework tonight.
All right, thanks.
Good job. You're welcome.